Okay, so for number one, calculate the change in Trump vote percent from 2016 to 2020 for each county. Create a histogram to display the result. So first I went to here, I got the information, I copied row F and I, and I made that into a histogram graph by going to insert, chart, and then so forth, making it a histogram. And then for number two, it was illustrate the relationship between the 2020 Trump vote percent and the household income with a scatter plot. For that one, I had to go back to this tab and get the household income and Trump vote here. And same thing, I go to insert, chart, and then except I choose scatter plot graph, which is here. And then number three, I did the same thing where it says illustrate the relationship between the 2020 Trump vote percent and bachelor's degree or a higher percent with a scatter plot. And I got the data from here in row H and I, or column H and I. And I did the same thing I did here, insert, chart, and scatter plot it. And then for the next question, what is the linear equation representing the trend line between the 2020 Trump vote percent and bachelor's degree or percent or higher? And that would be this graph. And it says pretty much that the linear equation is people who have bachelors tend to not vote for Trump. So it'll be this graph right here. And then it also says for this one, for this chart, on the scatter plot, it also says that the household income, people who have higher household income tend to not vote for Trump either. And that's what I get from this graph. And then what is the R-squared value associated with the trend line in problem number 4? The linear, so the trend line would be this number right here, which would be 54.8%. If it's in a percentage, right now it's in a decimal, so I have 0.548. Use the linear equation from problem 4 to estimate the 2020 Trump vote percent for a hypothetical county where bachelor's degree or higher percent equal 35. And for that one, I have it here on this equation. And I have negative 1.35 times 35 plus 86.1, which gives me, I have it written down, which gives me 38.85% from the linear equation. And then number 7, use simulation to estimate the probability of throwing 1 or more 6s when rolling 3 dice. That would be here, which I have all of these, dice 1, dice 2, dice 3. And for number of 6s on dice 1, with 1 dice, I have 174 out of 1,000 trials, which would equal 0.174. And then going to throwing 2 or more 6s when rolling 3 dice. For number 8, I have this one. Number 6 is on 2 dice, which is 347 out of 1,000, which is 0.347. And I have number 6 is on 3 dice, which is 526 or 526 out of 1,000, which is 0.526%. And then write that y hat equation for the regression model. I have that here, and the y hat equals 90.3545 plus the household income minus the urban percent minus the unemployment percent minus the bachelor's degree or higher percent. And that gives me that. And then which independent variable is the most significant? Then I have bachelor's degree or higher percent is the most significant predictor since it was the lowest p-value, essentially 0, indicating the strongest statistical relationship with the Trump vote percent in 2020. Which independent variable is the least significant? I have unemployment percent has the highest p-value, making it the least statistically significant variable in the model. And then I have 13 and 14, which would equal 70,000. Urban percent equals 50, unemployment percent equals 10, and bachelor's degree or higher percent equals 20 is approximately 64.58%. The household income equals 50,000, urban percent equals 40, unemployment percent equals 20, and bachelor's degree or higher percent equals 10 is approximately 65.6%.